Module, we're going to cover a great method of illuminating scenes, and that would be using high dynamic range images, also known as HDRIs. The dynamic range of an image is simply the ratio between the brightest and darkest areas of an image. And an example of a low dynamic range image would be this image here, consisting of a bowl of fruit sitting in a room with just a small amount of ambient light. I thought it would be appropriate to show this particular image since it's the cover of a great lighting book, which would be a good resource for anyone wanting to improve their lighting skills. Now, it's not Max or VRay specific, but rather it demonstrates practical application for any advanced lighting program. But anyway, this is a low dynamic range image. Notice the soft muted colors, the lack of any real highlights, and the lack of any view of a source of illumination such as the sun or an interior light. Now, an example of a high dynamic range image would be this image here, which does clearly show a source of illumination, the sun. But showing a source of illumination does not in any way qualify this image as a high dynamic range image. In fact, even though I pulled this example from a collection of actual HDRIs, there's really no way you can look at this image or any other image and say that it is in fact an HDRI. And the reason why is because an image is only a high dynamic range image only if it contains additional information which you can't even see just by looking at it. And such an image would only be an HDRI if it contained additional radiance or luminosity information that can't be shown on paper or even on the typical computer display. So why do certain images contain this additional information, or how are they made to contain this additional information? Well, in the real world, light exists all around us in a dynamic range well beyond that which can be captured by an ordinary camera. The average camera takes one photograph by opening the shutter once and recording the illumination. Special cameras that are made to capture HDRIs take multiple exposures at varying camera settings, and they combine the multiple images into a single high dynamic range image called a radiance map, not to be confused with irradiance map. Specifically, multiple exposures are taken with the shutter open for varying lengths of time, and as shown in these images courtesy of Lucas Sermon, these images are capturing the same scene, the same view with varying lengths of exposure time. And these radiance maps can be used in global illumination software to illuminate a 3D scene in a very realistic way that would otherwise require a great deal of effort and skill to duplicate. In other words, good HDRIs can be used solely or in conjunction with other light sources to really add an incredible amount of realistic illumination to your scenes with minimal effort. And as a side note, you can create HDRIs from a series of differently exposed images by an ordinary camera, but really high dynamic range images are best suited for cameras designed specifically to create these HDRIs. Now, a small amount of background about the history of HDRIs. A gentleman by the name of Greg Ward created a render engine back in 1985 called Radiance, and this renderer used the concept of high dynamic range imaging where illumination in a scene is calculated and stored as an unrestricted or open-ended value rather than as a fraction from 0.0 to 1.0 or as a value from 0 to 255 like those typical 8-bit images we see every day on our computers. His render engine specified the first high dynamic range image format, and for many years this was the only one. Today there are a few more. Although many of us in the business of creating 3D visualizations take our own photographs for use in our scenes, most of us have no need to create HDRIs nor the technical equipment or skill required to do so. This module is not focused on how these files are created, but rather how they work and how they can be used. Instead, we're better off purchasing good HDRIs from third-party vendors, and at the end of this module I'll point out some of the best sources out there. HDRIs have been around for a long time, and older examples may lack the quality, such as the color depth and illumination information that many of the newer HDRIs have. So choose your products wisely and make sure you know what you're getting. Hopefully by the end of this module you'll know exactly what to look for. So far in these modules we've used example scenes that have been, for the most part, illuminated without any real lights. And again, I've left lights out of the scenes to simplify the topics being covered and to help you better see individual features free of the effects of additional variables that lights would bring. Well, we're going to continue with this methodology in the first half of the module using an HDRI in the environment channel of a scene, but as you'll see, there are two main areas in VRay where HDRIs are utilized, and in the second half of the module we'll see how HDRIs can be used in the map channel of a particular type of light. So we'll look at how to implement and control HDRIs, and we'll look at several scenes that have used HDRIs to create a unique and inspiring mood. Okay, let's look closer at exactly what an HDRI is. In Module 3, I introduced the concept of luminosity and how taking a picture of midday sun results in a clipping of the pixels that want to be displayed at a higher range than the maximum 255 allowed by most image types. Well, the HDRI file type allows for an additional channel information, which is luminosity or radiance. The end result of this type of image is that it appears to look like any other image with common viewing programs, but it really contains the added luminosity information that can be used to create illumination in a scene. By mapping the HDRIs correctly, they can be used as a type of skylight, with some areas of a scene being more illuminated than other areas, depending on the orientation of the light source in the image. Now here I'm using a program called HDR Viewer, which you can find for free on the internet. But what I'm doing here exactly is I'm basically changing the exposure of this particular HDRI that we're looking at. Notice also that when I move the cursor around, this program shows the color values of each pixel in the image, not in terms that you would find in a typical image such as 0 to 255, but rather in values that can be in decimals at very low values or values well above 255, such as in the millions. So as I move this around, you see on the extreme ends of the image I have extremely low values, and it's not linear. As I move across the screen, it doesn't change, the value of the color doesn't change in a linear fashion. As soon as I hit the point in which the sun is shown in the image, the color value skyrockets, or it jumps significantly, almost in an exponential type of manner. Depending on the type of HDRI that you use, the HDRI itself may or may not be suitable as the background image in your scene. This image that I'm in right now would really not be suitable as a background image because it's too bland and too washed out, although it does a fine job as an HDRI. And here are a few HDRIs that would work well as backgrounds in a scene. They're obviously spherical images, but the important thing is that they just look good and they have nice vibrant colors. Using a different background image than the HDRI that you use in your scene is perfectly fine. The only important thing you need to remember is to find a background image that matches or fits the illumination provided by the HDRI that you use. Now let's look at a sequence of images where the HDRI that was used to illuminate the scene is also being used as the background. Here you can see the background in the distance and also reflected in the sphere. As the HDRI is rotated around the scene, you can see the illumination change accordingly. The side of the scene with the sun receives greater illumination than other parts, and you can see the shadows change as the background is rotated. So this HDRI is being wrapped around a virtual sphere that surrounds the scene, and different parts of the scene receive different types of illumination, depending on which part of the HDRI they're exposed to. Notice also that in these next few HDRIs, there's a completely different look to the bottom half of the HDRI than to the top. This is an important quality because realistically, if you're going to view the bottom side of objects in your scene, you wouldn't expect to see as much illumination as you would see appearing or originating from the top side. I'll talk about this later in more detail, but I just wanted to point out that many HDRIs have a unique appearance to the top half of the image that represents everything above ground or everything above the horizon line, and they also have a unique appearance to the bottom half of the images. In this particular HDRI, for example, the illumination on the surfaces oriented downwards to the ocean would reflect a different type of illumination than surfaces oriented upwards to the sky in this image. So with this HDRI, you could create such illumination that mimics the illumination coming from below the surface of the ocean. So HDRIs clearly provide a nice source of skylight, but the primary reason that skylight using this method looks so good is the subtle variance from one area of the scene to another. Take, for example, the following rendering. Here you can see on one side of the building a different type of illumination that you can on the other side of the building. Well, in the HDRI shown below the rendering, the sun is clearly visible, and in the rendering it was clearly oriented to the face of the side of the building that received the most illumination. Also, in other HDRIs, having the sun blocked by clouds or trees or anything else can also add a nice touch of realism. Because of the clouds in this image, which help to block the sun's light, certain parts of a scene may receive slightly less illumination than other parts, which are illuminated by parts of the image where light is not blocked by the sun. But HDRIs are not limited solely to these types of scenes, outdoor scenes with the sun. They can be a number of different kinds of images, such as indoor scenes. Okay, with all that said, let's get into it and start using some HDRIs in some scenes. As I just mentioned a moment ago, there are two main areas in which HDRIs can be used, in the environment channel and in the map channel of a particular type of light. Let's start by looking at use of HDRIs in the environment channel of a scene. The environment rollout acts as an override to the environment channel within the environment effects dialog box. So we need to go to the environment rollout, enable the override, click on the environment map channel, and select the VRay HDRI map type from the material map browser. And when we do, a map has not yet been loaded. We have to first drag this link to a sample slot within the material editor, and when we do, the HDRI map type appears with its unique interface. And here we can click the Browse button and locate the HDRI we want to use. When loaded, the HDRI can be seen in our sample slot, and with the controls and the parameters in the material editor here, we can control several things about the HDRI's effect on our scene. First, you can choose how this HDRI is to be mapped around your scene, and this is the most important part of the interface to get right, because different HDRIs have to be mapped differently, otherwise you're sure to get strange results. So let's look at each mapping type so that you know exactly how to handle each type of HDRI available. Probably the most common mapping type and the most simple to visualize in your mind is the spherical environment mapping type. This is similar to spherical UVW mapping, and it simply wraps an HDRI around a virtual sphere that surrounds your scene. The most common method of spherical mapping, the kind that you'll usually see most often is when working with spherical maps, is the latitude-longitude method shown here. These image types are twice as wide as they are tall. So in this image, for example, my image resolution is 700 pixels across and 350 pixels top to bottom. This image shows a complete 360 view of the surrounding environment. The bottom and top edges of the images occur at the poles of the virtual sphere, and notice there's a significant amount of distortion the closer you get to these edges. This distortion doesn't appear when mapped, but I mention it so that you know that when you edit these images with built-in distortion, editing these images can be quite difficult, especially the closer you get to the edge of the image. The next mapping type that I want to mention is the cubic environment mapping type. This mapping type is similar to box UVW mapping and places 6 different images or 6 portions of the same image on 6 sides of a virtual cube surrounding your scene. So here's the same environment we just saw, this time shown in cubic form. All adjacent edges align, and when each side folds in to form a cube, the result would be the same 360 view of the surrounding environment, only without the distortion that you get with spherical mapping. So in the spherical mapping image, the area around the sun is heavily stretched, and in the cubic image, there's almost no noticeable distortion. As a matter of preference, I would always use the spherical mapping type over cubic, but that does not mean that the cubic HDRI is not a worthwhile option. For example, if you want to have precise control over the illumination for each side of your scene, you can use different images for each side or orient the HDRI in such a way that a particular side of the cube aligns with a particular side of the scene. So on a more technical level, here's what's going on. One side represents forward, or north, and another represents backwards or south, and so on. Notice the lack of distortion in this image also. But this specific orientation is just one configuration for the cubic environment mapping type. Here's another one, and the only difference here is the placement of the part of the image representing south. Everything is the same, but it's important that you know that there are two cubic mapping types so that you're not confused if you ever purchase HDRIs and see two different types of cubic mapping. You don't have to change anything as far as mapping anything inside the material editor because all you have to do is select cubic mapping. I just wanted to point this out. Another very common type of mapping is the angular mapping type, also known as the light probe. And here's an example of a light probe image, and all it is a square with a circular area that contains all the HDRI information. So the area outside the circle doesn't contain any information at all, or at least any additional information other than what you see in the image here. The light probe is a 360-degree fisheye image, which really just means it shows a complete 360 environment, and it's heavily distorted around the edge of the circle. The center point of the circle shows the view forward or north, while the edge of the circle shows the view backwards or south. And editing this kind of HDRI is all but impossible because of the extreme distortion. The last mapping type that I want to point out is the mirror ball type. This is probably the easiest mapping type to create, and to create it, the cameraman just takes a picture of the mirror ball with multiple exposures, of course, and everything reflected in the ball is what makes up the HDRI information. It's not really a 360 HDRI like the angular map type. In fact, by all accounts, it's just a 180-degree image. And to create it, ideally, the camera should have a telephoto lens, and the photographer should take a picture of this mirror ball at a pretty good distance away so that the photographer and the camera's reflection is minimized. Doing so allows for the mirror ball also to reflect a full 180 degrees of the surrounding environment. Editing of this type of HDRI is possible, but it's best done in areas closest to the center of the image where distortion is minimized. The next thing I want to address, and a very important note of that, is the orientation of all these HDRIs. In their default orientation, the parts of each HDRI that represents the sky, or at least the area above the horizon line, is reflected in the top half of objects in a scene. And I was talking about this a moment ago, but I want to talk about it in more depth since I need to explain the controls in the material editor that allow you to change the orientation of HDRIs. So notice here in this image, courtesy of Dosh Design, that I see much more illumination in the top half of this dragon because, as logic would dictate, it's oriented upwards towards the sky where most of the illumination is coming from. When this HDR image was taken, clearly the ground was illuminated, which means therefore that light was bouncing off of it. Well, if light was bouncing off it, then it bounces upward onto the underside of the dragon. So my point is, HDRIs give you a great way to illuminate a scene nicely without even having to place any lights, although you certainly can to enhance lighting in certain ways. So if an actual model of this dragon existed and were placed in the exact spot that this HDR image was taken from, the illumination of the real model would look very similar to the illumination you see in the 3D model of the dragon here in the rendering. This assumes, of course, the HDRI was taken at sufficiently high quality with plenty of exposures and a good range in color. But you're not limited to the default orientation, and one of the great things about the HDRI map is the ability that you're given to rotate the map to achieve a particular look to the lighting. So you can rotate the HDRI around your scene using the horizontal and vertical rotation parameters here. By changing the horizontal rotation value, you can see that it changes the part of the HDRI visible in the sample slot. So if I rotate the map 360 degrees, the map will return to its initial orientation, which was 0 degrees. I can also rotate the map vertically, though the practicality of doing so is not as great as rotating the map horizontally around the z-axis. And let's see an example of this. So here's a simple scene with just a few objects, and the only source of illumination is the HDRI in the environment slot. As you can see in the material editor, I have an HDRI loaded with no horizontal or vertical rotation. When rendered, here's what I get. You can see the sun reflected in the sphere, and in this case the sun is over my right shoulder, and because of this there are shadows to the left and behind the sphere. The majority of the illumination is clearly coming from above the horizon line. So all I'm going to do now is apply some horizontal rotation, 30 degrees. And there in my sample slot the HDRI rotates. Now when rendered, here's what I get. The sun is clearly in a new location, as are the shadows. So if I keep applying horizontal rotation, my sample slot reflects all these changes. Likewise, I can rotate the HDRI vertically, but doing so is just not as necessary as applying horizontal rotation. Rather than rotating the image vertically to get the light to come from just such an angle in the sky, you're probably going to be better off finding the right HDRI that the light source already has positioned correctly in the sky. But just to show you, you can change the vertical rotation to change the location of the light source in your image. And here's the same scene with 180 degrees of vertical rotation. Notice in the sample slot that the HDRI is now upside down. Now when rendered, the majority of the illumination seems to be coming from below, i.e. below the horizon line. You could also just enable the flip vertically option to get the same general effect, although the actual result would be just a mirrored version of this. There's two additional controls in the HDRI map that are quite important. First, the multiplier is pretty straightforward and nothing new. Doubling this simply doubles the amount of illumination the HDRI wants to radiate. Remember that when a map is loaded in the environment channel multiplier cannot affect the illumination in your scene at all. The multiplier in the material editor would be where this control lies. Also, you can see that we have a gamma setting here, which you might find useful to play around with because you can use it to create some quick adjustments to the illumination in your scene and create some pretty nice moods, such as adding a more nighttime appearance to the HDRI that you're using. Alright, well that does it for coverage of the HDRI within the material editor and the environment rollout within the render scene dialog box. Now let's look at another way to use HDRIs as environment lighting, and that would be with the VRay dome light. In this case, I've saved the best for last because using HDRIs with the VRay dome is preferred and a far better way of using HDRIs because of the better results that aren't possible with using an HDRI in the environment channel. I mentioned this from the start of these modules that I didn't want to add additional variables into the mix early on so that things could be kept as simple as possible. Well, I've held off talking about lights as long as I can, and in this module here we're going to be talking about one type of light. In the next module, module 6, we're going to get into lights heavily, but here in the discussion of HDRIs in module 5 I simply can't avoid talking about one of the light types available, the VRay dome light. Although I need to explain some other parts of it, other parts will be left for the next module. So the VRay dome light is accessed through the regular light icon in the command panel, and in the drop-down list simply click on VRay to display the two categories of VRay lights possible. There are 3 different kinds of VRay lights, and each are found within the type drop-down list at the top of the parameters rollout. After switching to the VRay dome light, just click once inside the active viewport and you have your light. Well, the VRay dome light is nothing more than another form of skylight. It simulates atmospheric light bouncing off particles in the air, and it doesn't have some of the controls that the VRay sun and sky offer, such as the ability to control turbidity or haze, but it does have one feature that makes it very worthwhile in many types of scenes, and that's the ability to use an HDRI within the light. By loading an HDRI here in the VRay dome light, you're letting the HDRI control how the light is projected into your scene. But before we use an HDRI here, I need to briefly go over some basic principles about how this particular light type works. When you drop a VRay light in your scene, you can see that the light is oriented in your scene according to the viewport that you place the light in. So placing the light in the top view will cause the dome light to point straight down. Notice also that the dome light gizmo is actually a hemisphere. Now, when you place the light in your scene, location of the light means nothing, but orientation of the light means everything. So if I place the light above my objects and the light is oriented straight down, when I render, I get an orientation that allows for the maximum allowable illumination, which would simulate a rendering where the sun was directly overhead. Now if I rotate the dome 45 degrees about the local X or Y axis, then when I render, I get a reduced illumination that simulates skylight that you would have when the sun is lower on the horizon. And I can even rotate the sun or the VRay dome light even more so that it's pointed upward slightly. Now when I render, I get a kind of skylight that you would see if the sun were below the horizon, getting ready to turn into a nighttime scene. As with any skylight, the shadows are quite soft, and when the dome is oriented straight down, it can be difficult to say where the sun in the sky is. Sometimes you may want to use non-descriptive shadows like this, and sometimes you may find it necessary to place other lights in your scene that give you direct light or stronger shadows. Nonetheless, you can see that when we render the dome light oriented in certain ways, we can control quite nicely which side of the scene gets the majority of the illumination and which side is in shadows. And thus, we can better simulate conditions where the viewer knows exactly where the light is coming from. So you should be able to visualize this dome as a virtual hemispheric object surrounding half of your scene and casting skylight from just that half of your scene. So the strongest light comes from the direction that the light is oriented. As I just mentioned a moment ago, the position of the light means nothing. If I delete this current light and drop in another light and move it just above the objects in my scene and render, this is what I get. Now if I move the dome light a great distance away from the objects in my scene and move it much higher up, when I render again, you can see that nothing has changed. So position means nothing. One additional note, you may or may not have noticed that when I first placed the light in my scene, I immediately changed the multiplier value. The default value of 30 is usually far too high for exterior scenes, so I changed it to 1 and got a more usable illumination. For interiors, a larger value like 30, however, might be needed to get enough illumination to light the inside of a building. Likewise, the less illumination your skylight provides, the more apt the light is to produce splotches in the shadows. And this we'll look in more detail in the next module on lights, how to improve the shadow quality of any type of light. Okay, that's enough background information on the dome light. Let's start putting some HDRIs to work here. So within the texture section at the bottom of the rollout, you can click the map channel and select the HDRI map type from the material map browser. Like before, an HDRI is not actually loaded yet. We have to first instance this map into the material editor. And when we do, we have to click on the browse button to find the HDRI that we want. And I'll use an image like this and render out using the default settings. And when I do, my image looks like this. Now, this is not much of a scene to look at because I'm just using a simple scene as a tool to show exactly what happens with individual objects when illuminated by an HDRI and a dome light, as I'm doing here. To better see the kind of renderings possible with HDRIs using a VRay dome light, I'm going to scroll through a series of renderings along with the HDRIs used to create them. So the top image here is a project of a luxury condo development that I contracted out to the crew at Panorama 01. And as you can see, they did a really nice job with it. The lighting is really well done, and you might be surprised to hear that it was done entirely through the use of the HDRI image shown below the rendering. You almost can't put your finger on exactly what it is about the lighting in this image that makes it so nice and makes it so real, but it's a lot of little things. One is the variation from one direction to another. Notice how one side of the building is illuminated much differently than the other. And this is because the sun in the HDRI is projecting light from the direction that faces this side of the building. Also, there's a very faint tint of orange-red light striking these surfaces here. The shadows are also very soft and subtle, which reflect the time of day and the atmospheric conditions shown in the background image. So that's just one rendering, and here are some more. Scrolling through a couple more. These are some really nice renderings that were created just by changing out the HDRI image. And as you can see, there's a lot of different looks, a lot of different moods to these images. And my personal favorite here is a fantastic night image, which is a type of rendering many VRay users try to create but often struggle with. Well, with good HDRIs, it's really quite simple. Now I want to show off a couple images of a student of mine, Padilla Hutton, who runs Avocado 3D. Here she's achieved a wonderful mood to create a nice sunset image. And she explained that she did this using the HDRI shown below, as well as a VRay sun to help bring out the strength of the sun's direct light. And here's a few more. And you can clearly see that HDRIs give you some amazing results without the extensive work that would otherwise be required. Okay, before we end the discussion on the HDRIs, there's just a couple more things that I want to point out. First of all, going back to a little history on the HDRI, back in 1999, the movie studio Industrial Light and Magic began developing a new and improved type of HDRI format known as OpenEXR. It was first put into use a couple years later in the first Harry Potter movie, and ILM states on their official OpenEXR website that it uses this format now on all its motion pictures. They've released this format type for free distribution and use by the public, so it becomes a nice option to use. You can visit www.openexr.com for a thorough technical explanation about what it does better than the standard HDR format type. I just wanted to mention it so that you know it's an option that is supposed to provide a higher dynamic range and color precision than the previous format type, as well as a better compression. For these reasons, many HDRI producers such as Dosh Design have begun releasing images in both HDR and EXR formats. But when you load the VRay HDRI map type in Max, and when you click on the Browse button and then the Files to Type drop-down list, you can see that the VRay HDRI shader does not support the EXR format type. You can still use it by loading it as a bitmap, but on a personal level, I still prefer the simplicity of the HDRI file because, by all accounts, it really yields perfectly good results. When you load an EXR file type, you're forced to do a little more work in the OpenEXR configuration dialog box to get the results that you need. And this is a plugin developed by Splutterfish, and if you want more information on how it works, just click the Splutterfish link within the help section here in the dialog box. And finally, a good HDRI library is really important to be able to duplicate many different types of moods. And some good sources for HDRIs are Dosh Design, Hyperfocal Design, and HDRI Studio. Dosh Design has several different collections of high-quality HDRIs in multiple mapping types and in the HDR and EXR formats. And they also have some good resources for showing you how to implement HDRIs and giving you a little bit more information about how they work. Hyperfocal also has some great collections, quite a large collection. They're devoted towards HDRIs, so you might want to check them out as a source for HDRIs. And HDRI Studio has a great product line that might suit your interior needs. They sell a wide range of bundles of HDRIs, but they're really quite different from most of the HDRIs you might have seen for sale. They basically have various colors positioned in precise locations around the HDRI image, and when used in an interior scene, they can really give you a nice look. Best of all, you can purchase a bundle of specific color types, and as an example of how they look, when I click on one of their samples and rotate the HDRI around the objects in the scene, you can see how nice these images are and how much changing the orientation of the HDRI produces drastically different results. Well, that does it for HDRIs and Module 5. Let's briefly review what was covered here in this module. First of all, I think that the information that I presented in this module is much easier to grasp than any of the previous modules. It's pretty straightforward. Even though the science behind HDRIs is quite complex, the subject of HDRIs is really quite simple in comparison to most areas of advanced lighting. And because of this, HDRIs provide a quick and simple way to achieve great lighting that would otherwise take a lot of work to set up using conventional lighting configurations. So HDRIs can act alone or in conjunction with other light types. Whether you use other lights or not is simply a matter of choice and the specific results that you need. Something that I didn't really hit on, I mentioned that HDRIs can produce nice soft shadows, especially when used by themselves, but you can also achieve stronger, more crisp shadows using high quality HDRIs with a high color range and a lot of exposures. Although the default multiplier value of 1 is sufficient for most exteriors, higher HDRI multiplier values are usually needed for interiors, and you want to do that in the material editor. You want to adjust that in the material editor. Don't forget to match the background image to the lighting that you find in the HDRI or whatever the HDRI provides. Otherwise, your renderings simply won't look realistic. If you use HDRIs, I recommend using the VRay dome light option because it's far superior to the environment channel option, both in quality and rendering time. And use correct mapping when you use HDRIs and change the orientation as you need in your material editor. And don't forget that a nice collection of HDRIs is important to achieve the mood that you want. And I explained some options for finding good resources for HDRIs: Dosh Design, Hyperfocal Design, and HDRI Studio. That concludes Module 5.